Alright, so we're going to look at the different types of thermodynamic questions we might come across in this class. So we got to calculate the energy transferred when a block of aluminum at 80 degrees Celsius is placed in 1 liter or 1 kilogram of water at 25 degrees Celsius if the final temperature becomes 30 degrees Celsius. So we're going to write down what we know. Aluminum, starting temperature is 80 degrees Celsius, final temperature is 30 degrees Celsius, so its change in temperature is 50 degrees Celsius. Water, starting temperature is 25 degrees Celsius, final temperature is 30 degrees Celsius, so the change in temperature is 5 degrees Celsius. We've got the mass. We got the mass of aluminum. We do not know. We know that the mass of the water is 1 kilogram. And we know the specific heat of aluminum is 900, and we know the specific heat of water is 4,184. So once we write down what we know, we're going to find our formula sheet, and we're going to find that formula sheet and find that the formula that the change in Q is equal to mass times specific heat times change in temperature. We're going to take a little side note here, and we're going to look at the units. So mass is kilograms. Specific heat is listed as joules per kilogram times degrees Celsius, and temperature is Celsius. So we're going to cancel Celsius, Celsius out, kilograms, kilograms. So the change in Q is calculating for us how many joules of energy is being transferred from the aluminum to the water. So we need to calculate that change in Q, but in order to calculate change in Q, we need to make sure we know both the mass and of the aluminum. So we need to know the mass of aluminum. So what do we know and what can we go ahead and do? Well, we know how much energy the water is gaining. The water has a mass of 1 kilogram. It has a specific heat of 4184, and we know it changed to 5 degrees Celsius. So the water is going to go ahead and gain 2,100 or 21,000 joules of energy. So if the water is gaining it, that means the aluminum has to be losing that. So the change in Q for the aluminum has to be equal to the 21,000 lost. So we're going to set that 21,000 lost and set that equal to our mass, which we don't know, times our specific heat, which is 900, times our change in temperature, which was 50 degrees Celsius. So 900 times 50 is 45,000. So 21,000 divided by 45,000 gives us the mass of that aluminum in this situation being 0.46 kilograms or 460 grams.